tangent lines. Now, you may remember from geometry, a tangent line is a line that touches the graph or touches a circle or something like that at one point. It does not cross at that point. Not cross. And the reason I want to specify it does not cross at that point is because the line may be tangent at one point, but cross somewhere later. Let me show you what I mean. So I've got a graph, blah, 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 blah. Okay, so if I wanted to draw in tangent lines, let's think about what that would be. So if I have a tangent line right here, it's touching right there at that point, not going through the graph, not crossing, just touching. So this one would be a line pointing up. So that one would have positive slope. That's kind of neat. If I were right at the top of this hill, it's not going to go through. I mean, because if I was going through, I could draw as many as I want, but just touching there, I can only draw one. And this would be a line. That line would have like a slope of 0. It's straight across. Now, it's tangent right here, but if I kept going with it, it would cross over here. But I'm only talking about being tangent right there. So this would have a slope of 0. And then if I was talking about right here, it's going down like this, and it would cross down here. But when we're talking about the tangent lines on a curvy graph, it's touching at that point. It may cross later, but it's just touching there. Now, what we're going to be doing is finding the slope of a tangent line, which is also known as the slope of a curve. So let's think how that's going to work. So I guess this is just as good a way of doing it as any. So if I had, I'll use this, let's draw this one a little bit better. How would I find the slope of that line? So any point on this graph is a point x and f of x. This point, let's say it's at A, the y value would be f of A. So this would be the point A, comma, f of A. Now, what we end up having to do here, really, is I can only find points on this graph. Well, I need to get super, super, super close to that point A, f of A. I want to get so, so close, but I need 2 points to find the slope, right? I mean, like, so a point up here would be x, comma, f of x. And I'm going to slide that point as close as I can. So the way we can get closer and closer and closer is by using what is known as a limit. So the slope is going to be the limit as, so let's talk about what we'd have over here. Y minus y, because it's the change in y's over the change in x's. But I'm wanting to find out what happens as this x value and that a become the same thing. In other words, the slope at a certain point, not between two, but at a certain point. So I'm going to find the limit as x approaches a. So let's go ahead and do an example using that notation. So we're going to find the tangent line. To y equals 3 over x at the point 3, comma 1. Well, To find the equation of a line, I need to know a point and the slope. Well, I've got a point. I need the slope. So we need to find the slope. That's our first step. So I'm going to use this limit to find the slope. So it says to put in f of x, which y is the same as f of x, so that's going to be 3 over x, minus that function evaluated at this x value. So a is 3, and I should have put 3 in here. We're looking at when x becomes 3. So this would be 3 over 3, 3 over 3, over x minus 3. I can simplify that up a little bit. That's going to be 3 over x minus 1 over x minus 3. Okay, so I really don't like that fraction within a fraction. So as long as I multiply the numerator and denominator by the same thing, I'm okay with the algebra gods. So I'm going to multiply the top and the bottom by x. So 3 over x times x would give me a 3 minus 1 times x, which is x, over, and I am not going to distribute that, and I'll tell you why. 3 minus x is almost like x minus 3. It's just here the x is negative and 3 is positive, and then they're switched here. So there's a little trick we can do. I can factor out a negative 1 from that numerator. When I factor out a negative, it's going to change the signs. So in other words, it flips it. If you go back and redistribute that negative 1, you'll get 3 minus x back. So if I do that, then these two can divide out. Remember, because x is not ever really getting to 3, it's just getting super and super close. And I'm going to be left with the limit as x approaches 3 of negative 1 over x. Now I can actually plug in 3. So the slope is going to be negative 1 over 3. Now, I found the slope. We're trying to find the equation of the line. So I'm going to use point slope. Now, depending on how WebAssign wants the answers, remember you may have to go back and simplify, solve for y or something, but this is an equation of the line. So I'm going to do y minus y1. Here's my slope, and then x minus the x value. If all they ask for is an equation of the line, you're okay. Now, if they want it in slope-intercept form, you would just solve for y. If they want it in standard form, that means they don't want any fractions in it, and they want the x's and y's on the same side. So this would be slope-intercept. If I wanted it in standard form, I'd multiply both sides of the equation by 3 and get 3y equals negative 1x plus 6. And then I would move the x to the same side as the y. If they don't specify how to write the equation, then this is a perfectly good answer. Now there's another way that we can write this limit, and I'm going to talk about where it comes from too. So again, if I have my graph, okay, And I'm trying to find the slope at that point. So here's A. And so the point is A, comma, f of A. Well, instead of doing it the way we did it just a second ago, what if I said, I want to talk about the distance between A and the next point as being something called h. So then that would make this x value A plus h. So it would be at A plus h, comma, f of A plus h. And then we're going to let the distance go to 0. It's just a different way of setting it up. So you'll see both of these notations. We're going to let the distance h go to 0. And so we would have f of A plus h minus f of A over A plus h minus A. Now the beauty of this one is that this denominator simplifies. The a's cancel out, and we get that the change in the x values is just h. It is a little bit of a simpler form in some ways. Let's see if we can use that one. Okay, so number 2 for my examples. Find the tangent line to y equals x cubed minus 2x plus 3 at 1, 2. Again, we've got our point. Our A is 1. And so we're going to plug everything in. So f of A plus h, that's going to be 1 plus h. So I'm going to actually write that. That's going to be 1 plus h minus f of 1 over h. Now I've got to plug in 1 plus h into this function. So I'm going to kind of come off to the side here. Well, first, I'm just going to plug it right in. All right, so 1 plus h is going to replace all the x's. So that's going to be 1 plus h cubed minus 2 times 1 plus h plus 3 minus, what do I get when I plug in 1? So 1 cubed minus 2 times 1 plus 3, that's going to give me, is that a 2? The problem on this one is going to be the simplifying. You're going to have to pull out some old algebra tricks. How do I cube that? And please don't put that's 1 cubed plus h cubed, because it is not. That is really 1 plus h times 1 plus h times 1 plus h. I've got to multiply the first two together. So 1 plus 2h plus h squared. Then I'm going to distribute the next one in. So I'm going to go ahead and distribute this 1 into everything here, and then the h. So I have 1 plus 2h plus h squared. Then distribute the h, and I get h plus 2h squared plus h cubed. And by the way, there is a faster way to do this. It's called the Binomial Theorem, but you can always come off to the side and do it by hand. So 1 plus h cubed turns into all that junk. Now I need to distribute the negative 2. And then I have plus 3 minus 2. That ends up giving me, what does that give me? Plus 1 all over h. Right now, I can't let h go to 0 because I'd be dividing by 0. So let's simplify a little bit more. All right, I'm going to rearrange this a little bit. H cubed plus 3h squared. Then I have a 3h and a negative 2h. That's a plus h. I have 1 plus 1 minus 2. Ooh, couldn't we factor out an h from the numerator? Now what happens with the h's? They can cancel. Now I can plug in 0 for h. And I get, oh, lo and behold, it's just a 1. That means the slope is 1. Now I'm going to go ahead and I'm going to write this one in point slope because it is faster and a lot easier. Now what we're doing here actually has something to do with what are called derivatives. The derivative, oops, I forgot an I, of a function is defined as, so it's f prime. The derivative of a function at x equals a is defined as the limit as h approaches 0 of f of a plus h minus f of a over h. What does that look like? That is the slope of the tangent line. So anytime you're hearing these words derivative, all it is the slope of the tangent line. That's really all we're finding. Oh, this paper's so thin. Okay, so I want to do a couple more examples. So we're changing up the words. Find the derivative of this function at x equals 2. This also means to find the tangent line at x equals 2. But not the whole equation, just the slope. So what we're finding is f prime of 2, that's how we usually say it, is going to be the limit as h approaches 0. So this is my a. So I'm going to have to do f of 2 plus h minus f of 2 over h. Two plus h goes in for all the x's. You could write h plus 2 as well. That would work. Oop, I forgot the squared. Whoops, minus, oh, I forgot the f of 2, didn't I? F of 2 means I'm going to plug in 2 for all the x's, and I would have 5 times 4 plus 3 times 2 minus 1, 26, 25. We've got to simplify. So I'm going to come off to the side. 2 plus h times 2 plus h. It's going to be 4 plus 4h plus h squared. And there's a 5 on the outside. So that means I'm going to have to distribute that in just a second. I'll go ahead and distribute the 3 here. And that's going to give me a negative 24 down at the end. Distribute, so that's 20 plus 20h plus 5h squared plus 6 plus 3h minus 24 all over h. I feel like I messed up somewhere. That was a -1. Oh no. I knew I messed up because that's a 26, that's a 26. I'll show you how I know I messed up. 20 plus 6 and this should cancel out. Oh, and they didn't. Now notice, all of these have h's in them. This is an h down here. It's going to divide out. So I'm just going to go ahead and divide everything up here by h, or factor it out and then cancel. But what I'll be left with in the top, so be 23 plus 5h. And I've already divided the h into the top. So now I'm going to let h go to 0, and I get 23. So f prime of 2 is 23. The slope of the tangent line at 2 is 23.